Welcome to yet another episode in our probability theory lessons. And today, in this episode, we are looking at probability trees. Now, probability tree diagrams are very convenient, is a very convenient way of tackling many probability problems. And to illustrate them very well, we shall use examples. And in our example number 1, it says the probability that I am late for work is 0.05. Find the probability that on 2 consecutive mornings I am late for work twice. And part B, I am late for work once. First of all, we shall need to first define our events. Let's first define our events first. Let event L denote late for work. So L complement will now denote, of course, not late for work. Someone is about to say early for work, but not being late can mean you're either early or on time. So the complement of late caters for both. So I'm late for work twice. It means on the first day, this person was late for work or not late for work. Late for work is 0.05 probability. Not late for work means that 1 minus 0.05 giving us 0.95. On the second day, there is being late and not being late. There is being late and not being late. Still the same probability, 0.05, 0.95, 0.05, and 0.95. And what we have formed here is actually a tree diagram that we are talking about. Mainly use a ruler for us to have smarter diagrams. Now, I'm late for work twice. It means you are late for work on the first instance and you're late for work again on the second instance or on the second day or second morning. Now, so the first morning is 0.05. These are independent events. The second morning is 0.05. So 0.05 times 0.05 calculator gives us 0.0025. That is being late for work twice. Part B, being late for work once is 2 ways. It might be that you are late on the first day, then you are not late on the second morning, or it can be you are not late in the first morning, then you are late on the second morning. So the first one, you are using the first branch of late. You are here. That is 0.05. Then not late, which is 0.95. Or you begin with not late as 0.95, then late On the second morning, 0.05. Calculators. This whole thing gives us an answer of 0.095. You can see how tree diagrams have been able to simplify our work very well. We go on question number 2. They are saying a die is thrown 3 times. Find the probability that of throwing a 2 on just one occasion. A die is thrown 3 times. What is the probability of throwing a 2 on just one equation? Shall again use a tree diagram. Now, when you throw a die, now the event is having a 2. Let me first define the event. Here, the event T means having a 2. Now, the throws are 3. Now, the first throw, you might get a 2, or you might fail to get a 2. Then you now go for the second throw. We go now for the second draw. Now, on the second draw, you again might get a 2, or fail to get a 2. You may get a 2, or fail to get a 2. Remember, the die has 6 sides, so the probability of throwing a 2 is 1 out of those 6 possible outcomes. So probability of failing to get that 2 is 5 out of 6. The same thing applies here, because the die you are throwing is not changing. Now, on the third throw, on the third throw, again you may have two outcomes. So the branches keep growing. And in each case, you're either having a 2 or not a 2. Either a 2 or not a 2, either a 2 or not a 2, a 2 or not a 2. Same die being rolled again, so you expect the same probabilities. Now, our tree diagram is done. So what is the probability of throwing a 2 on just one occasion? So probability of throwing a 2 on just one occasion, out of all the 3, it might be You throw a 2 first. Now the first branch. If you throw a 2 first, then no 2 and no 2. 2 first, then no 2 and then no 2. Or you may have no 2, you get a 2 and then no 2. That's also 1 2. If you began with not having a 2, you got a 2, then on the third throw you didn't get a 2. Plus, you may not get a 2, you go back, you don't get a 2, and still not a 2. You don't get a 2, then on the third time, that's when you get a 2. In all these three cases, you have only got 1 2. So the first branch, it was 1 out of 6 times 5 out of 6 times 5 out of 6. The second one, following the branches, it was 5 out of 6 times 1 over 6 times 5 out of 6. Then the third one is 5 out of 6 times 5 times 5 out of 6 times 1 out of 6. So this one we end up getting 75 out of 216, giving us the answer as giving the answer as 25 out of 72. That is the answer we have got from following all those branches. We now got question number 3. Question number 3 says a box contains 6 red pens and 3 blue pens. A box contains 6 red pens and 3 blue pens. They select a pen at random. They note the color of the pen and they return the pen to the box. This procedure is repeated the second time and then a third time. Find the probability that all of obtaining Roman 1, 3 red pens. Roman 2, 2 red pens and 1 blue pen in any order. Then Roman number 3, more than 1 blue pen. So we have the first branch. We can get a red here, or we get a blue. Probability of getting a red is 6 out of 9. Probability of getting a blue, therefore, is 3 out of 9. In the samples. That is for the first time. Now, for the second time, you can again go back and choose. Still you have red and blue. Red and blue. Now, since we note the color and return, that means we restore the number of pens which are already there. So you take a red, you note the color, you bring back the red still remains 6. So the sample space here is not changing because it is picking with the replacement. 6 over 9, 3 over 9, 6 over 9, and 3 out of 9. Then we go for the third time. Still we have red, blue, red, blue, red, blue, red, blue. Same probabilities. 6 over 9, 3 over 9, 6 over 9, 3 over 9, 6 over 9, 3 over 9, 6 over 9, and 3 over 9. The key thing here is that the key issue here we have is that we pick a pen from the box, we note the color and return the pen, which means we are not in any way changing or altering the size and the composition of the sample space. Now, Roman 1, what do they want? 3 red pens. So one probability of picking a red, picking another red, and then picking another red. So it is 6 over 9 times 6 over 9 times 6 over 9. When you work out that one, you'll get 8 out of 27 as your answer when you simplify. Roman numeral 2, 2 red pens and 1 blue pen. 2 red pens and 1 blue pen. Still, we can follow the order. We can pick red first. Red, because we want 2 red and 1 blue. And pick red, again red, then blue. Red, red, and then blue. There, I picked 2 red and 1 blue. Or I can pick red, then blue, then red. Red, then blue, then red. Alternatively, I can start with blue, then I pick red, then I pick red. Blue, red, and then red. So the first branches, if you are following them, red, blue, red, 6 out of 9 times 3 out of 9. No, it is 6 again. Times 6 out of 9 times 3 over 9. The second one is red first, 6 over 9. You on this one, red, blue, red. 6 over 9 times 3 over 9 times 6 over 9. Then the third one is blue, red, red. So it is 3 out of 9 times 6 over 9 times 6 over 9. By 3 once, by 3 3, by 3 twice, 3 twice, 3. So it is actually 4 out of 27. And the same thing which appears to the other ones, though they are mixed up, but they still have the same thing when you reduce. So 4 out of 27 times 3, we shall get 12 out of 27, which you can simplify to have by 12 divided by 3 is 4. 27 divided by 3 is 9. So the answer here is 4 out of 9. More than 1 blue pen. More than 1 blue pen means either 2 blue pens or 3 blue pens. Either 2 blue pens or 3 blue pens. There, you would have got more than 2 blue pens. No, more than 1 blue pen. Either you have 2 blue pens or you have 3. Now, this number part 3 can be done in 2 ways. Either we go back through the same procedure, we list the possible ways of getting 2 blue pens, then we add there the 3 blue pens, or alternatively, we can, this is in part 2, we got 1 blue pen. Now we can add there the probability of getting, especially even in Roman 1, we have the 3 red pens, which means that is 0 red pen. So we have 0 red pen, and then we have 1 blue pen. If we add those ones, they give us the complement of the third. So we can add those ones, then we subtract it from 1. 1 minus the sum of the first 2, then we get the complement, which is more than 1. Let's first do that approach, then we come back and do the other approach of doing it throughout. Don't want to scroll this page because I want to still use our tree diagram later. Let's begin with the I cannot easily bring back what we have just done there. So let me do the second approach. I have rubbed off my solutions before actually being able to use them. Let me see if I can recoup them and we use them. Read number 4. Read question number 4. Yes, we had 8/27 for 3 red pens. So probability, let me put it here. Probability of more than 1 blue pen is equal to 1 minus probability of less than 2 blue pens. One minus, now less than 2, because when they say more than 1, it means 1 itself is excluded. So 1 and 0 do not fit in more than 1. So more than 1 excludes, equal to 1 and equal to 0. That forms the complement of more than 1 blue. So 1 minus, now the one which is probability of less than 2, 0 and 1. So the first one was 8/27. And we have also the second one was 4/9. Remember, our first one was 3 red pens, which means 0 blue pens. Then the second was 2 red pens, 1 blue pen. So we have 0 and 1. And we want more than 1. So whatever is left out of Roman 1, Roman 2 is what we want, which is the complement of what we already have. So when we work out that one, we get, we see on the calculator, 1 minus 8/27 plus 4/9. This one gives us 7/27. 7/27. 27 as our answer. So that one is the first approach of doing it, like you want to use the idea of the complement. Using the idea of the complement, we get that. Now, what if you want to do it full force, the way I've been doing for the others? Let me clean off this. Now we want more than one blue. More than one blue means two blue or three blue. Two blue or three blue. Let's see if it will still give us our answer as 7 out of 27. If it gives back our answer 7 out of 27, we know that we are right. So this one will involve us to have one where you have two. Now two blue pens, it can be red first, then blue, blue. Red, blue, blue. Red, blue, blue. Red, blue, blue. That is two blue. Or you can have blue, red, blue. Blue, red, blue. Or you can have blue, blue, then red. Blue, blue, then red. That is the shortest chance of getting two blue. Now getting three blue is blue, blue, blue. Blue, blue, blue. Now we start working out. Red, 6/9. We are now on the first branch. Let me try to use another color first so that you can be able to trace that one very well. This is red, blue, blue. So it is 6/9 times 3/9 times 3/9. That is red, blue, blue. Then we have blue, red, blue. 3/9 times 6/9 times 3/9. Then we have blue, blue, red. Blue, blue, red. This is 3/9 times 3/9 times 6/9. Then lastly, blue, blue, blue. Blue, blue, blue. 3/9 times 3/9 times 3/9. We reduce this 3 and that's 9 goes with this 9 by 3, 2 by 3, 3. So here we basically have 2 out of 27. 2 out of 27 is the same as here, is the same as there. So 2 out of 27 times 3. This gives us, so this 3 gives us 2 out of 9. 2 out of 9. This is a third, a third, a third. So 2 out of 9 plus 1 out of 27. 2 out of 9 plus 1 out of 27. And the answer is 7 out of 27. Good. That is the answer. The same answer that we had got before using the idea of the complements. Now, part B. is very important. They are saying repeat part A, but this time find the probabilities if at each selection the pen is not returned to the box. Repeat part A, but this time find the probabilities if at each selection the pen is not returned to the box. Let's first now clear off everything. Now things are changing because this time you are not picking with replacement. This time we are picking but not bringing back, which means as we pick a pen from the box and we don't return, every time we pick, our sample space, total sample space will reduce by 1, and the particular color we have picked also would have reduced. That one would have caused by reduction by 1 in the particular color that we have picked from the box. This one would be very interesting, picking without replacement. Let's go. This time we have 6 red, 3 blue. But this time when we pick, let me call it here red 1, blue 1. The first red, the first blue. When we pick at first, it is 6/9, 3/9. Now this time we don't note and return. So here we pick the red. Now the reds have become, so let me even draw here to make it simpler for us to understand. Let me draw here a new box, because now the sample space is changing. Now here we picked red, they become 5 red and 3 blue. Note that reds have reduced by 1, then there were a total of 9 as sample space before, now they are 8. Here we picked the blue. Now here the blue are 2, but the reds are still 6. So this time now, the red 2, let me now call it red 2 on the second pick. This time it is 5 out of 8. This time blue 2 is 3 out of 8. Now what has happened here? Due to this picking, now the reds are 4, blue are still 3. Here when you pick the blue become 2, reds are still 5. Probability here down, we have 6/8 correspond to red 2. Then blue 2 is 2 out of 8. Now when you pick a red from these 6, they become 5 red. The blues are still 2. When you pick a blue here, the blue is 1. The reds are still 6. Now we go back for the third. Now, this is red 3 correspond to 4 out of 7. Note that the sample space showed by the denominator keeps on reducing by 1 at each instance. And each and every instance, when you add the 2 branches, they should give you a 1. because the two are exhaustive events. One out of 7. Good. Now let's answer our questions. Common 1. 3 red pens. The same thing we had done there before. It will be getting red is picking red the first time, red the second time, and red the third time. 6 out of 9. We are now here. Change of color for clarity. We are here. We move red, red, red. Now, if you follow those branches, it is 6 out of 9 times 5 out of 8 times 4 out of 7. By 4 ones, by 4 2, by 2 ones, by 2 3, by 3 ones, by 3 3. And the answer is 1 times 5 is 1, 3 times 7 is 21. So the answer is 5 out of 21. Now for part B, for Roman numeral 2, 2 red pens and 1 blue pen in any order. 2 blue pens, 1 red pen. So the first movement we shall make is red, red, blue, red, red, blue. So it will be red, red, blue. Plus, that is 2 red, 1 blue. Or you can take red, blue, red, red, blue, red, red, blue, red. Or you can take blue, red, red, blue, red, red. Red one, if you are following the path, is red one is 6 over 9. We are here. Then 5 over 8. Then 5 over 7. No. This is 3 over 7. Then 3 over 7. The second one, red one, 6 over 9. Blue 2, 3 over 8. Then red 3, 5 out of 7. Then lastly, blue, red, blue. Blue, red, red. Blue, red, red. 3 out of 9 times 6 out of 8 times 5 out of 7. These things are basically the same things numerically when you look at them. by 3 ones, by 3, 3, by 3 ones, 2, by 2 ones, 4. So it is 5 out of 28 times 3. 5 out of 28 times 3. 5 out of 28 times 3. This will give us 15 out of 28. 15 out of 28. Now you can follow these branches. I'm leaving Roman numeral 3, more than one blue pen. For you, the learner, you try to work out for more than one blue pen by following those branches. More than one means either getting 2 blue or all the 3. Alternatively, adding these 2 answers we have got, then we say 1 minus 5 over 21 plus 15 over 28. That is for Roman numeral 3. 1 minus 5 out of 28. I'm trying to put on my calculator aside, which is besides me here. Then 15 out of 28. And it is giving me the answer as 2 of 7. No, it is 5 out of, I put a wrong thing. 5 out of 21. Sorry. I put the wrong thing in the calculator. I put 5 out of 28 instead of 5 out of 21. Answer is 19 over 84. That is for Roman numeral 3. You can roll the video, you look at how we did it in 2 ways. For the first case, when we were removing and replacing, and you try to apply it here and see what will give us. So you try to do the same thing now, Roman numeral 3, by listing all the possible outcomes which result more than blue pen, more than one blue pen. That is red, blue, 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 red, blue, 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 red. Those are the 3 ways of getting 2 blue pens. Then you add there, of course, now the 3 blue pens, blue, blue, blue. So when you add those 4 outcomes, the answer will still give you 19 out of 84. But I'm leaving it to us as an exercise to tackle and see if we get the answer as 19 out of 84. Allow me go to the last question. I'm holding it number 5. I had put there number 4, but I discovered that I had made a typing error in it, so I removed it. So number 5, of a group of people studying at A level in schools in a certain area, 56% are boys, 56% are boys, and 44% are girls. The probability that a boy of this group is studying chemistry is a fifth, and that a girl of this group is studying chemistry is 1 over 11. Find the probability that a pupil picked at random from this group is a girl studying chemistry. Part B, a pupil picked at random from this group is not studying chemistry. Then part C, a chemistry pupil picked at random from this group is male. Let's start with the tree diagram. First of all, define the events. D is a boy. She is a girl, or you can even make it be complement. C is chemistry, and because now C complement is not chemistry. So the boys and the girls are in a ratio of boys 56 over 100, 0.56, girls 0.44. A boy studying chemistry, that is probability of chemistry given is a boy. Boy studying chemistry is a fifth, which means a boy not studying chemistry is a 4 out of 5. A girl studying chemistry is 1 out of 11, and a girl not studying chemistry is of course now 10 over 11. Part A. A pupil at random picked from this group is a girl studying chemistry. So the one probability from part A, probability of a girl studying chemistry, which is 0.44 times 1 over 11. So 0.44 divided by 11, the answer is 0.04. That's our answer. Or in fraction form, that is 1 in 25. 1 in 25. That is 0.04. Let me confirm with the question here. Let me confirm with the question. I want to check with the answers directly and see if they agree with what we have got there. That is the of a group yes, studying A level in schools. That is ADB number 8. Number 8. Yes, 1 in 25 is okay. Then we go to part B. A pupil picked at random from this group is not studying chemistry. So he's not studying chemistry. It might be a girl not studying chemistry or a boy not studying chemistry. A boy not studying chemistry or a girl not studying chemistry. So girl not studying chemistry 0.44 times 10 over 11. Boy not studying chemistry 0.56. You're following the branches. 0.56 times 4 over 5. Let us work it out very fast. Mm, 0.44 times 10 over 11 plus 0.56 times 4 over 5. And the answer we are getting is 106 over 125. That is when we add those two. Correct. Then lastly, part C. Part C says a chemistry pupil, Victor Harnum from this group is male. A chemistry student is male. So we already know that the people we have chosen is doing chemistry. Now we want to find the probability that that child we have picked is male or is a boy. So what are we looking at there is what we saw in episode 2. That probability is conditional probability. But what do we already know? We know that is a chemistry pupil. So it is probability of male, which is boy, given that we know is already doing chemistry. This will be probability of boy doing chemistry out of probability of doing chemistry. Now we want to go back to look for chemistry by adding boys plus girls who are doing chemistry. We shall get from the previous one. Because a boy who does chemistry, that one I've already got. A boy who does chemistry, okay? We don't have that. A boy who does chemistry, we shall follow the branch for boy doing chemistry. That is boy doing chemistry. So it is 0.56 times 1 out of 5. It is a boy doing chemistry. Now down, either we can choose to use complement because we have already seen that in part B we worked out a child not offering, a people not offering chemistry. So it will be 1 minus not offering chemistry to get us those who are offering chemistry. If not, we'll still follow the branches. We can go boy chemistry, then girl chemistry. Boy chemistry and then girl chemistry. Also works. So up we have 0.56 times 1 over 5, 0.112. Then down we have 1 minus 106 divided by 125. This is 0.152. And the answer is 14 over 19. The answer is 14 out of 19. Correct. We can verify our answer by using the other method for the denominator of not using the complement but moving the branches. For those studying chemistry, we look at boys chemistry, girls chemistry, and we add the two. We shall still end up with the same answer. Thank you for following our episodes on tree diagrams. Keep tuned for the next episode, whereby we shall be discussing something to do with one and only one situation, and then we shall extend our knowledge and look at arrangements, combinations, and permutations. And that will be the end of our probability theory episodes. Don't forget to like and subscribe.